Have you ever stopped to think about how a simple pink rock can be transformed into a gourmet product, into lamps that illuminate Zen environments, or into stones for cooking meats to perfection? Today, I'll take you step by step through how the famous Himalayan pink salt is created and manufactured, a journey that blends geological science, extreme mining, and an ancient art that has survived for centuries. A few hundred kilometers south of the Himalayas in Pakistan lies a mineral colossus that has lain dormant for more than 800 million years. Every day, some 300 miners enter stone tunnels that snake through the darkness for more than 40 kilometers, maintaining a constant temperature of 18 degrees Celsius, as if the mountain were breathing on its own. The atmosphere is silent, barely broken by the metallic sound of picks, drills, and the occasional conversation between workers who liven up the dust. To extract salt, the veins are drilled and small gunpowder charges are introduced, which, when detonated, release gigantic blocks. It's not a pyrotechnic spectacle, but each explosion resonates like thunder in the depths. Once the rocks have been knocked down, the initial sorting begins. Pieces with intense pink, orange, or crystalline white hues are separated from the rest. Only these, the purest, will make it to the surface. Short trucks and underground trains adapted to navigate tight curves transport between 10 and 15 tons per trip. Each year, the system extracts more than 400,000 tons of salt from the mine, traveling distances equivalent to several times the planet's orbit. Once outside the mine, the dust-covered stones enter a suction chamber that removes loose debris. They then pass onto a conveyor belt with pressurized water nozzles, which fire jets of water at 50 bar mixed with a very mild food-grade detergent. Nylon brushes rotate to loosen the clay and any adhering impurities. A final rinse with demineralized water leaves the surface completely clean. The rocks then pass through a hot air tunnel at 70 degrees Celsius, which reduces the humidity to less than 0.3%, monitored by infrared sensors. The next step is thermal roasting, at approximately 200 degrees Celsius for 15 minutes, which seals the microfissures and sterilizes the material without altering its natural color or flavor. Finally, a filtered airflow cools them to about 35 degrees Celsius, the ideal temperature for handling. Optical cameras inspect each piece individually, verifying color, purity, and possible cracks. Those that pass the test receive a QR code with the date and batch number before moving on to the milling or artistic cutting area. The result: flawless, dry, and stable crystals, ready to be transformed into table salt or decorative sculptures. The roasted blocks are discharged into a jaw crusher, which reduces them to fragments less than 40 millimeters in size. From there, a hammer mill pulverizes them at 2,800 revolutions per minute, while a blast of cold air prevents the color from changing due to heat. The salt then passes through a 3-level vibrating screen: 4 millimeters for coarse salt, mineral baths, 2 millimeters for the grinder or bakery, and 0.8 millimeters for fine table salt. Fragments that are still larger than 6 millimeters are redirected to the mill for reuse, ensuring zero waste. An optical RGB camera system scans 18,000 grains per second. If an impurity is detected, a pulse of air instantly expels it. The entire process is coordinated by a central PLC, which records the temperature, weight, and speed of each batch, linking the data to its QR code. In this way, traceability is absolute from the origin to the final packaging. In this phase, the blocks, which can weigh up to 20 kilograms, are carefully moved to the cutting area. There, circular saws equipped with diamond blades are used, capable of sliding over the rock with millimeter precision. The artisans pre-mark the cutting lines, taking into account the crystal's natural veining, its transparency, and the nuances of its pink color. Each block is cut according to its internal structure, maximizing the stone's natural beauty. Once the base pieces are obtained, the most artistic part of the process begins. The rocks are placed on slowly rotating vertical wheels, where metal tools, similar to those used in ceramics, shape them into cones, spheres, or cylinders. It's a task that combines technique, strength, and sensitivity. Although the scene might resemble a potter molding clay, the material here is a hard, crystalline mineral that demands precision and patience. A central hole, 50 millimeters in diameter, is then drilled using hardened steel hollow drill bits. This conduit will accommodate the bulb socket and the electrical system that will convert the rock into a lamp. Next comes the surface finishing stage. The pieces are sanded using fine grit orbital sanders, which remove irregularities and smooth the edges. Grits ranging from 240 to 600 are used, achieving a texture so polished it feels like marble. When the shape and polishing reach the desired level, the artisans proceed with manual polishing with damp cloths, intensifying the natural shine and highlighting the stone's internal tones. During this visual inspection, each master chooses which will be the luminous side, that is, the part of the block that will best diffuse the warm light characteristic of these lamps. Salt is naturally hygroscopic, meaning it absorbs moisture from the air. For this reason, packaging is carried out in a sealed clean room with stainless steel walls and H14 HEPA filters. The environment is maintained at 30% relative humidity, an ideal level to avoid lumps without generating electrostatic charges. The product arrives from the mill through a vibrating elevator to a central hopper with laser sensors that regulate the flow. From there, two packaging lines work in parallel: borosilicate glass bottles, cleaned with ionized air before filling; trilaminated Doypack bags, formed and heat-sealed after receiving the exact dose of salt. Before sealing, 99.999% nitrogen is injected to remove oxygen and prevent oxidation. Each bag is sealed with an 8 mm airtight thermal seam, resistant to moisture and light. All packages then pass through a dynamic scale that processes up to 180 packages per minute, with a maximum tolerance of plus or minus 1 gram. If there is a deviation, the pneumatic system detects it and removes it for reprocessing. Smart cameras verify the integrity of the closure and label printing. Finally, high-precision printers record the date, time, batch, and QR code, which links to a database where everything is recorded, from the source vein to machine calibration. Approved products are packed in moisture-proof cardboard boxes, shrink-wrapped, and stacked on climate-controlled pallets ready for export. During the 1990s, the Himalayan pink salt trade was very different from today. At that time, Pakistan exported a ton of salt to India for a mere $30, a paltry price compared to the product's potential. Once across the border, the salt was repackaged, labeled as an Indian product, and resold in Europe and other regions at prices up to 10 times higher, taking advantage of the lack of export infrastructure in its country of origin. In other words, Pakistan extracted the resource, but the major profits remained in the hands of the intermediaries. With the turn of the century, the landscape began to change. The Pakistani government realized it had a product with enormous added value and decided to reverse this trade inequality. Incentive programs were designed to encourage the establishment of processing plants within the country. Quality regulations and international certifications were created to guarantee the purity of the product. And, for the first time, a global marketing campaign was launched to position pink salt as a symbol of national identity and a premium product. Thanks to these measures, trade took a new direction. Today, containers loaded with pink salt, processed, packaged and certified in Pakistan, depart directly from the port of Karachi to some of the world's major logistics hubs: Dubai, Rotterdam, Hamburg, New York, and Los Angeles. At these destinations, the salt arrives ready for distribution to supermarket chains, gourmet restaurants, and specialty wellness and home decor stores. The logistics process is carefully planned to maintain product integrity. Within Pakistan, salt is transported in 25-kilogram sacks for the retail market and in 1-ton industrial bags for wholesale. Each unit features sealed polyethylene inner liners that prevent moisture absorption and prevent cross-contamination during transit. These loads are transported using forklifts equipped with integrated scales, allowing the exact weight of each pallet to be monitored in real time before shipment. When the final destination is less than 15 kilometers away, rail transportation is a more efficient and less polluting alternative. For international routes or longer journeys, container ships equipped with refrigeration and humidity control systems are used, ensuring that the crystals maintain their original structure, color, and flavor throughout the weeks of sea voyage. Each container ships with quality certificates, mineralogical analysis, and full batch traceability, ensuring that the product reaching the end consumer is exactly the same as that extracted from the Kiura mines. This transparency is one of the pillars of pink salt's global success. Today, international trade in this mineral exceeds $250 million annually and continues to expand. The Himalayan pink salt brand has established itself as a symbol of purity and sophistication, and Pakistan, which for decades was merely a supplier of raw materials, has become a global leader in the direct export of this natural product. Behind every jar or bag that arrives at stores is a logistics network that combines modern infrastructure, strict health standards, and meticulous planning, ensuring that the salt that originated in an ancient mountain ends up intact, shiny, and ready to be enjoyed on tables around the world. Chemically, Himalayan pink salt is composed of 97% sodium chloride, with traces of 84 minerals and trace elements such as calcium, magnesium, potassium, iron, and zinc. These give it a light mineral flavor and a characteristic tone, as well as superior purity due to its underground origin, free of modern contaminants and microplastics. However, its nutritional contribution is minimal. It does not replace supplements or correct iodine deficiencies. Its consumption should be in the same moderation as the World Health Organization recommends for any type of salt. Among the most widespread myths are its supposed power to alkalize the body, balance energies, or emit beneficial ions through the lamps. Independent studies have shown that these effects are negligible compared to those of a natural waterfall or air purifier. What is real is its aesthetic value, a warm, relaxing, and visually attractive light. From an environmental perspective, the Kura mines and surrounding areas use the chamber and pillar method, which leaves up to 60% of the rock mass intact to maintain stability. With estimated reserves of 6.7 billion tons and an extraction rate of 400,000 tons per year, the resource could last more than 16,000 years. Furthermore, as it is a dry mine, no brine or liquid waste is generated, reducing the ecological footprint to a minimum. Himalayan pink salt combines natural history and industrial precision. Every grain that reaches your table entails a journey of millions of years underground, controlled explosions, drying ovens, optical machines, and artisan hands that transform a block into a work of art. It's not just about seasoning your food, but about appreciating a chain of processes that unites geology, chemistry, engineering, and design. And although myths surround it, its true value lies in its purity, its texture, and its natural beauty.